Hello, so today we will be discussing about the motion of a projectile. And if you remember, I said that this portion actually comes first in the unit, whereas resisting medium comes at a later part. Okay, but anyway, we are doing it now after resisting medium. So let us see. You have actually done some of the things that we are going to do. You have done it in your higher secondary days, but anyways, let us have a look at it. So what happens, any object that is thrown under gravity is called a projectile. So even if I am throwing this pen, okay, if I am throwing it in this way, this one will be called a projectile. So it can be anything. And also remember that over here, we are discussing the motion when there is no air resistance or no other forces. Okay, so this is in contrast to the things that we had done previously, where we were studying motion in a resisting medium. But over here in the motion of projectile, we are not taking into account the effects of air resistance. Okay, so any object that is thrown in gravity, so that is called a projectile. What we will be interested in, okay, we want to see how does it look like, how does the part of a projectile looks like, which you already have an idea. So if you are throwing a projectile from O, it will reach a point G in the ground, and it will follow this path. So because you are throwing it, you will be throwing it at some direction, alpha, and there will also be some velocity that we will be projecting it. Okay, so U, it is called the velocity of projection. Alpha, it is called the angle of projection. What we want to do over here is we want to find what is R, what is T, what is H. As you can see in the purple box above, T, it is called the time of flight, R, it is the horizontal range, H is the greatest height. So what exactly are those terms? T, which is the time of flight, it is the time taken from O to G. Okay, when the particle is moving, so the time to cover the full motion, it is called as the time of flight, time taken from O to G. And what is the horizontal range? Range, it is this OG. And the greatest height H, as you can see over here, at the midway point, the height H is the greatest. So this height that we are measuring, this one, it is called as the greatest height. So one thing that you have to be very careful, if we want to find expressions for T, R, and for H, we have to use the known quantities. The known quantities over here, they are the velocity of projection, which you can easily measure. The angle of projection can be measured, and similarly, since we are throwing it under gravity, so the motion is because of the influence of gravity only. So we will also require the value of G, which is the acceleration due to gravity. Also, I must mention over here that if you are throwing a particle, the velocity at any point, okay, the velocity at any point, if you are just saying the velocity, it just means the tangential velocity, which is measured from the tangent. So that is why from O, you are throwing in this way, okay, it is tangentially. Okay, so keep that in mind. Why am I saying that you have to keep the direction of the velocity in check? Because when we are deriving these expressions, okay, you will have to use the three basic equations of motion. If you remember the three basics of equations of motion, they are these: V minus U equal AT, S equal UT plus half AT square, and V square minus U square equal twice AS, where A is the acceleration, T is the time, V is the final velocity, U is the initial velocity. Okay, so we will have to use these to derive the three equations, T, R, and H. One thing that you must remember is when you are using those three equations of motion, you first have to mention the direction. Okay, because you are dealing with vector quantities. Velocity is a vector quantity, acceleration is a vector quantity, so you have to be very careful about the direction that you are measuring those s, that you are measuring s, a, that you are measuring v, velocity. Time, it doesn't matter. You can time is independent of space for these equations. Okay, but we can use that for now. Okay, but as you will see, okay, maybe when you go for higher studies, time is in fact dependent on space. Okay, but over here we will use that time is independent of space. It doesn't matter whether you are measuring in any direction, the time it will remain the same. Okay, so what I want to say is this. If you see, okay, for the part of projectile, which is happening in this way, you will see that there is this velocity which is in this direction. Okay, sorry, this is u. Okay, this at an angle alpha. And if you remember, g, it is acting downwards. So we cannot use u and g directly, okay, because they are in different directions. If you have to use those three equations of motion that I have specified, you have to first choose the same direction. But luckily, because they are vector quantities, we can resolve in any direction that you like. Okay, and what we will do over here is we will resolve everything along the x direction and along the positive y direction. So we will resolve all velocities, all accelerations in these two directions. So what I want to say is this. Okay, so u cos alpha, it will be the velocity along OX, and u sine alpha, it will be the velocity along OY. Similarly, what is the acceleration due to gravity along OX? 0. It is 0, the acceleration due to gravity along OX. Acceleration due to gravity along OX, and minus g will be the acceleration due to gravity along OY. So because we have fixed the positive x direction and the positive y direction, that is why we are resolving everything along OX and OY, all the vector quantities that will be involved. Okay, and also if we are measuring the distance, okay, so suppose we have this one, this point over here P, okay, maybe I will use over here. If I am measuring the distance of this point, or what I can do, I can either measure it directly like this, or I can use the two directions. I can use along OX and the direction and the distance along OY. Okay, so similarly, the distance, acceleration due to gravity, and velocity have all been measured along OX and along OY only. Okay, so now let us try to derive. Okay, at the point G, when the particle is over here, at the point G, how much is the horizontal distance? Horizontal distance, it's equal to the range, because this one is the range. This one is the range, so that's why horizontal distance is r. What about the vertical distance? What about the vertical distance? The vertical distance of this point, if you are measuring it upwards, it has no height, right? So that is why the vertical distance will be equal to 0. So now what I will use the equation S equal ut plus half at squared. So over here, if we are doing it for the horizontal motion, so S, it will be r instead of u, what I will be using? I will be using the horizontal component of the velocity, which is u cos alpha. Time, it is the time taken from O to G, which is capital T. And plus half, what is the acceleration? It is only the component of the gravity, acceleration due to gravity in the horizontal direction, which is 0, t squared. So that's why we will be having this first equation, u cos alpha t. What about over here? Again, we will use the same equation, s equal ut plus half at squared. S, it will be 0. U, now because we are using the vertical direction, so that is why it will be u sine alpha. Time, it will still be t. Okay, because the particle is at g. For the particle to be at g, it takes a time t. Plus how much is A? Acceleration due to gravity upwards, it is minus g t squared. So if you simplify this one, you will be getting t equal 2u sine alpha upon g. So this is the required expression for the time of flight. Therefore, okay, you can substitute t over here, you will be getting u cos alpha 2u sine alpha upon g, okay, which is the required expression, which is 2u squared sine alpha cos alpha upon g. Okay, so t and r, they can easily be solved. Okay, what about h? Okay, h, it will be somewhere here, right? Okay, so now let us try to derive the expression for h. Okay, so over here, for the particle to reach from here to here, it will take half of the time. The full time taken, it is t, so half of the time taken will be t by 2. Or simply, we can even use this one. Okay, so again, h, now instead of u, because we are measuring the distance vertically, so it will be u sine alpha. T, the value of t, it will be 2u, it will be t by 2 plus half. The value of A, it is the acceleration due to gravity that is measured upwards, will be minus g, and over here will be t squared. So if you simplify this one, let us see. T, it is 2u sine alpha upon g minus 1 by 2 g, and t squared again will be 2u sine alpha upon g squared. So you will be having 2u squared sine squared alpha upon g minus 1 upon minus 2 u squared sine squared alpha over here will be t by 2. T by 2 whole thing square, so that's why over here we will be having 2g 2u. Okay, again I made a mistake, over here it should be 2g. So over here, if we simplify, we will be having u squared sine squared alpha upon g minus, okay, just make some simplifications over here, 1 by 2 u squared sine squared alpha upon g. So we will be having, if you simplify this one, you will be having g u squared sine squared alpha upon 2g. So this is what we will be having. So this is the required expression for the greatest height. So one thing again I just want to point out, if you are measuring in the horizontal direction, all velocities, distances and acceleration will also be in the horizontal direction. If you are using the vertical direction, all distances, all velocities, and all accelerations will be in the vertical direction. Okay, so we have finished deriving these three expressions for dr and h, and you must remember them. Okay, we will have lots of problems that we will be basing upon these formulae. So now what we will do now is this. Okay, we will derive the equation for the path of a projectile. Again, it is something that you had done in your higher secondary days. Okay, if I say derive an expression for the path of a projectile, what exactly do I want to find? I want to find, okay, I will just take any point in this path. Okay, I can take it over here, I can take it over here, I can take anywhere. Okay, maybe take it as xy. I will find an equation, okay, in x and y, which an equation which this path satisfies. So that is what I mean when I want, if I want to find the equation of the path of a projectile. So this point, it will satisfy that equation. Again, I repeat, if I have to find the equation of a path, I will just take any point xy in its path and then find an equation involving xy and the known quantities. Again, the known quantities over here, they are alpha, u, and g. Okay, since xy, okay, now let us try to derive that equation for the path. Since xy, it is a point. So over here, the horizontal distance, it is x. The vertical distance, it is y. And you must remember that g, it is acting downwards. But we have to be very careful in measuring the velocities and accelerations. We have to choose the direction. Okay. Okay, when the particle is at point P, this is how I start. Okay, actually you will start with let alpha be the angle of projection, let u be the velocity of projection. Okay, and after that you will write this when the particle is at P. Any point P, xy, we have that the horizontal distance is x. And the vertical distance, it is equal to y. Okay, so now we will again use this equation as equal ut plus half at squared. If you are using it for the horizontal motion, if you are using this equation for the horizontal motion, what we will be having, we will be having x. Instead of s, I will write x. Instead of u, I will write u cos alpha. And let t be the time taken from here to here. Let this time taken from O to P, let it be t. Do not confuse this small t with capital T. Capital T, it is the time taken from O to this point G. But small t, it is only to reach this point P. When the particle is at any point P, after time t, okay, we will be having this plus half. Instead of a, I will be having 0. Okay, because the component of the acceleration of gravity, it is 0, t squared. So we will be having x equal u cos alpha t. And what about the vertical motion? For the vertical motion, again s, it will be equal to y. Instead of u, you will be using u sine alpha t. And over here you will be having minus half gt squared. Again, the acceleration due to gravity that is measured upwards, it is minus g. So that's why we are having this. So substitute this equation 1 over here. Because I am deriving an equation for the path, so I don't want this time to be present in the equation. Time is again another variable, which is something that I don't want in this equation. Okay, so that's why I will substitute time over here. from equation 1, you will be having this. Time, it is equal to x by u cos alpha. Half g, again time, it is x by u cos alpha. Square using 1. So after doing all this, we will be having the required part, which is y equal sine alpha by cos alpha. It will be tan alpha, so you will be having x tan alpha. U and u will get cancelled, minus gx squared upon 2u squared cos squared alpha, which is the required part of a projectile. Okay, so over here, if you remember, this one is in fact an equation of a parabola. Okay, so what we will do next time is we will actually try to transform this one into an equation of a parabola, because over here you are having this shape. This shape, it is like a parabola. If you remember a parabola, there are 4 different types. A right-handed, a left-handed parabola, an upward parabola, as well as a downward parabola. So this one, it is looking like a downward parabola. What we will do next time is we will transform this one into the equation of a downward parabola. So next time we will really see that the equation of a part of a projectile is indeed a parabola. Until next time.